Assalamualaikum warahmatullahi wabarakatuh. We are from Group 6 and today we will present about speed control of series DC motors. As can be seen from the formula, this is a formula of speed-torque equation and it is derived as Vt over K flux minus by R A plus RF. RA is the armature resistance and RF is the field resistance divided by K flux square multiplied by torque, load torque. So there are three methods to control the speed of series DC motors, which the first one is by adding a resistance in the armature circuit. The second one is adjusting the armature voltage. And last but not least, adjusting the field current. So for first method, which is by adding resistance to the armature circuit, the torque equation is given by KCIA squared. The flux is assumed to be linearly proportional to the armature current. Flux equals to CIA. Equation above shows that for a given load torque, the armature current of the motor is constant. The change in armature current is only proportional to the change in the load torque. So by assuming flux equals to CIA, the equation is shown below. We just need to replace the flux with CIA. Okay, next. What do we mean by adding resistance to the armature circuit? Adding resistance in series with the armature circuit can be seen from the right hand side of the slide, which is just by adding adjustable resistance to the armature circuit. If we assume that the load torque is unchanged, then the armature current is constant. In addition, if the supply voltage is unchanged, then the motor speed is reduced when a resistance is added to the armature circuit. This is due to the increase in the speed drop. For the formula, we can use the same formula as previous slide by just adding adjustable resistance with RA and RF.
Thank you Akif Amani giving 1 point on how to control speed of series DC motor. As have been mentioned, there are three suggested methods to control the speed of series DC motor, which Akif already explained one, and I will explain another point, which is the adjusting the armature voltage. In this method, we use equations of 6.29 as have been mentioned by my friend Akif. Based on the equation of 6.29, the change in armature voltage has a similar effect on the series motor as the insertion of an armature resistance. For a constant torque, the motor current is constant and the first term omega naught in equation 6.29 decrease with the decrease of voltage. The second term of the rate of change of omega remains unchanged. This results is in a decrease in motor speed. Since the voltage must be kept at or below the rated value, this type of control is suitable for speed reduction below rated speed. If you look on the circuit diagram as shown on the top right corner, we can see that the circuit in this circuit, the voltage source is connected in series with the series winding, which consists of armature and field winding. The armature is connected in series with the variable resistor, which is used to adjust the armature voltage. When the variable resistor is set to its maximum value, the full voltage of the source is applied across the armature and field winding, and the motor runs at its maximum speed. As the variable resistor is decreased, the voltage across the armature is reduced, causing the motor speed to decrease. The variable resistor can be adjusted to achieve the desired speed of the motor. However, it's important to note that the relationship between armature voltage and motor speed is not linear and depends on other factors such as the load and on the motor and the field current.
Assalamualaikum. My name is Muhammad Hanif Fikri Zulkifli. I will present about the controlling speed by adjusting the field current. If a resistor RFADD is inserted in shunt with the series field winding, the field current is reduced by a ratio equal to the formula 6.31, where Rs is the resistance of the series field winding. This is based on the Ohm's law, which states that the current through a circuit is directly proportional to the voltage and inversely proportional to the resistance. By adding a resistance in shunt with the series field winding, the total resistance in the field circuit is increased, which reduces the current flowing through the circuit. RFADD refers to an additional resistance added in shunt with the series field winding in a DC motor. The purpose of adding this resistance is to control the amount of current flowing through the series field winding, which affect the strength of the magnetic field generated by the motor. If the field flux is assumed to be proportional to the field current IF, where C is the constant of proportionality, then the field flux can be controlled by adjusting the field current. By changing the field current, the strength of the magnetic field generated by the motor can be varied, which affect the motor speed and torque. If the field flux is assumed to be proportional to the field current, then the formula become like 6.32, and also the load torque equation will become like 6.33. The above equation 6.27 will be modified to include the newly added resistance. The new equation for the speed will become like 6.34. By substituting the equation 6.32 into 6.34, and then the final equation will become like 6.35. This type of speed control must be performed with care so the current of the motor is not excessive. This can be seen by examining equation 6.33 below. If the torque is assumed constant, the armature current will increase if RFADD is reduced. That's all from me. Thank you.